Dear students, good afternoon. Today we shall discuss on the another important concept in the main memory management is called as a segmentation. So in the previous video lecture I already mentioned the contiguous memory allocation called as non-contiguous memory allocation called as an paging. Now take up another variety in the non-contiguous memory allocation, that is called as an segmentation. So paging is nothing but it is a one contiguous fixed size memory which we call it as a block, and the frame is physical address and page is a logical address. So physical address frame and logical address page are of fixed size, and page is placed in the respective frame because as they are of the same size. That is one concept called as a paging. Now we move on to the another important concept called as a segmentation, wherein the physical memory is divided in variable size segment. So in contrast with the paging where the memory size is fixed, that is pages logically, frame physically are fixed size, but here in segmentation the actual physical memory is divided into variable size of items called as a segment. Now each of these segment is assigned with what we call it as a unique segment number. So segment has been assigned with the segment number, and how the memory management is done, it is done through what we call it as a segment table, and which is indexed by segment number. So each segment has an entry is provided, what we call it as a base address, and then an segment correspondingly the size of the segment. So base address of the segment, at what initial address the address of that particular segment starts, and what is its length. Say consider it starts at 1000 byte, and then what is its size, say 500, in the sense from 1000 to 1500 will be the size of that particular segment, and the second may be 1501 to 1510 because size is only 10 bytes. So in this way it is a variable size. So now I repeat, the memory management is done through segment table, which is indexed by the segment number. For each segment, it has an entry that provided the base address of the segment and then the size of the segment. The logical address contains segment number. The logical address is generated by the CPU. What it contains? It contains a segment number. That is what we call it as an S. And then offset within the segment. It is an offset. Offset is length. Within that particular segment, which memory location is to be accessed, it is nothing but the offset. That is what we call it as an offset within that particular segment. So using this segment number, system obtains the base address of the segment. Fine. Then it makes a check to determine. Now please try to understand, there is some tricky aspect here. The segment number is obtained, fine, and then it has a fixed length. Now whenever a memory access is requested, in that time the memory request, the whatever access is requested, that should be less than the size of that particular segment. If it is greater, then it is not possible. If it is smaller, then only it is possible. Now how it is been done is, please observe here in this particular diagram, which clearly shows the program has generated the logical address having the segment, and this is an offset. Now this segment number is an index to the what we call it as a segment table. This segment number is an index that contains base as well as the size. Now the point here is, this offset, what we are trying to access, should be less than the size of that particular frame. If you are trying to access 1000 location in that particular segment, if the location has only 900 spaces, then it is an illegal memory access. So what is important here is D should be less than Z. So what is a D? D is a request made by the logical address to access the location, which should be less than the segment size. Z is a segment size here now. It should be less than the segment size. So if it is less than the segment size, then it adds to the base to get the physical address. How it is been done here? Please try to take up an example here which will give you some clear idea. So see, this is a one variable size segment program what we are talking about. Is one subroutine, segment 0, segment 1, segment 2, segment 3, segment 4. There are 4 to 5 different segments. Now each with the variable size. See, segment 0, 1, 2, 3, 4. Segment 0 size is 1000 and base is 1400. 1400 in the sense it is its initial address here now. It will add 1000 to it. So 1400 to 2400 would be the memory addressable location of the segment 0. Then 6300 initial address, 6300 to plus 400, it's the size. So 6300 to 6700 would be the memory locations that can be accessed as a part of the segment 1. So in this way it is proceeded. Now see here, we shall take up the same. So segment 0, it starts from 1400 to 1000 its size. So 1400 to 1000 is 2400 in a sequence, that is segment 0. Then segment 3, see what is the segment 3? Base address is 3200. 3200 to 1100. 3200 to 1000 is 4300. Segment 3. Then from segment, that is segment 2. It is a segment 2, 4300 to 400 plus 4300 added with the 400 is 4700. So in this way we are trying to we get the memory location which are of the variable size. Here size is totally different now. It is like not like a paging where each frame size is fixed. No, here 1000, 400, 400, 1100, 1000, any, all may be different. Now see, try to find out how the memory access is being done. Segment 2 is having the 400 bytes long and it's begin at the location 4300. Segment 2 begins at 4300, size is 400. Now if any reference of byte 53 is mapped where 4300 plus 53, 4453, it is a valid access because starts with the 4300 and if you try to access 53rd byte, it is possible because its length is 400. Similarly, you take up the segment 3. What is the segment 3? Segment 3 size is 1100. Fine. So if any byte you are trying to access 852, so 1100 is its length, and if you are trying to access 852nd byte, it is possible because size is 1100. You are trying to access 852, so it is possible. So 3200 to 852 added, so memory location is 4052. It is possible. But whenever you make a reference to 1222 of segment 0, what is the segment 0 now? Come out here, segment 0. Base is 1400, not an issue, but size is 1000. So maximum size itself is 1000 and you are trying to access a location of 1222 of segment 0, which would be an error as this segment crossed 1000 byte. Got a point clear? So in this way the segmentation is done, and this is a diagram explaining the segmentation. Fine. So paging and segmentation are two different issues. Now coming to the next aspect, what we call it as a last part in this particular main memory management is segmentation with paging. Segmentation with paging is actually what it does is logical address space is divided into what we call it as a number of segments now, which are variable size. However, each segment is divided into fixed number of pages. Please try to understand. See, segmentation is variable size, paging is fixed size. Now how they are trying to combine segmentation and paging here is, let variable size segments be there. There are the blocks, variable size blocks. But within that particular segments or a blocks, what they are trying to do here is each segment is divided into fixed number of pages with fixed size. That is most important thing. And the memory management is done through that particular segmentation table. That is another important aspect. So each segment has an entry into the table, and each entry contains the segment page table and the size of the segment page table. So logical address contains the segment S, and then page number P, which will be accessed to D. So in this way the segmentation with the paging is being done, not widely used, but however at a certain level it is also used. So most important aspect in this particular the first part of the memory management here is we should concentrate on paging segmentation in the form of non-contiguous allocation, and in contiguous allocation we have first fit, best fit, and the worst fit are the points on which you have to concentrate. So in the next class we will talk about the another important last part in the third module is called as an virtual memory. Thank you.